Hello there. Welcome to the Engineering Mechanics video lectures. In this video lecture, we are going to see when a particle is going to be moving in a curvilinear path. So that means the curvilinear motion it is gaining when it is moving in a curved path. As you know that in the previous video lectures we have seen the same kind of curvilinear motion of a particle. We have analyzed, we determined some of the field parameters by using the kinematics. But in this lecture we will see they are using the kinetics, right? The kinetics here we are considering the force. What is the cause for that also? That means we are calculating the velocity, acceleration, including the force which is acting on that member, right? That is the definition of the kinetics we are going to be saying. So what is the cause for that motion also we are going to be taking into the consideration, and then we are finding the field parameters. So then what we are exactly finding from this part, right? So in this case what will happen, we are going to be developing the equation of motion. What is the equation of motion in this case? Most of the time this equation of motion deals with the force, mass and acceleration of a particle which is moving in the curvilinear mode, right? In this case what will happen, in the equation of motion we are developing for the curvilinear motion of a particle, right? In the previous sessions we have seen when there is a rectilinear motion is going to be there. So there we developed in the translatory direction. For this one we are going with the curvilinear motion. So then what we are going to do? So when a particle is moving in the curvilinear path, then what happened, its acceleration also is going to be trying to move in the same direction, because the resultant force is going to be acting on that member. The particle acceleration also gain in the same direction. It means the direction of the particle and the direction of the acceleration is going to be the same. Then it is going to be that means it is in the positive direction. So exactly what we are going to do in this equation of motion, we generally using the Newton's second law. What is the Newton's second law we are using? The applied force is going to be directly proportional to the acceleration of that particle. Alright? So by using that we are going to be trying to see how it is. There we can see for the time being I have taken the rectangle components. Right? And further we can take it the tangential and normal components also. So there we can see I have taken the particle which is moving in a curvilinear path. So the particle is going to be moving in this direction. Right? It is not in the x direction, not in the y direction. So I have taken at one point of that one is going to be the point P I have taken. So then what will happen? As we know, the F is equal to ma formula is going to be there. But when I am going to be resolving this resultant force, it's going to be getting the two components. That's going to be one is in the x direction, another is in the y direction. So the particle is going to be covering x as well as the y simultaneous, but the path is the curvilinear. So in this case what will happen, I am going to be taking the resolving the forces, the resultant force. So one is going to be in this direction, another is going to be in this direction. So that's going to be f of x, sigma f of x, suppose sigma f of y I am going to be taking. So these are the system of the forces are acting on this member that is equal to the mass into acceleration, right? I am taking that one. So the same I am going to be taking, that is equal to the mass, that means the acceleration towards the direction of the force I am taking. So this I am going to be taking max, and similarly in the upward direction may I am going to be taking. Can you see the sigma f of y is equal to may. The sigma f of x is equal to max. So that I am going to be writing here. Sigma f of x is equal to max. Sigma f of y is equal to may. Then these two equations we are going to be called equation of motion. Right? So this way we have developed in this equation. Then in the other part here, the equations of dynamic equilibrium. What is the equation of dynamic equilibrium? That we can say Alembert principle. The Alembert principle is nothing but the application of your Newton's second law we are going to be seeing. In this also we are going to be writing sigma f minus ma is equal to 0. This equation we are going to be seeing. then this part we are going to be say that's going to be the Fi. Fi is nothing but your inertia force also we are going to be considering in our particle motion. So for this one I am going to be taking over here. So can you see the same rectangle coordinates I have taken x as well as the y coordinates we have taken. The same path I am going to be considering here. This is the path and the particle P I have considered. As we know that the inertia force is going to be always acting opposing the motion of the body, right? So then I am going to be taking, this is going to be your point P. So I am going to be taking here sigma f of y and sigma f of x. In this case also it is going to be subjected. So this direction sigma f of x and this is going to be sigma f of y, right? So that's we have taken. Then can you tell me how the inertia force is going to be acting on this member? Even though the acceleration is going to be acting in this direction, right? In this direction also acceleration is going to be acting, but the inertia force is always acting to the acting of the member. It is going to be in this direction. This is going to be max. I am going to be writing, right? All the horizontal forces are going to be towards the right side, but inertia force is going to be acting opposite direction to stop the motion. And similarly, the inertia force in the y direction, this way we are going to be getting, right? So the same equations we are going to be rewriting over here. The sigma f of x minus max is equal to 0. So can you see this one? The same equations we are writing over there. And similarly, sigma f of y minus may is equal to 0. Then these equations we are going to be calling equations of dynamic equilibrium. And further also we are going to be simplifying this equation that I can write sigma f of x equal to 0, sigma f of y is equal to 0 also. This way also I can write it, right? Suppose if there is going to be another components also we can use it, there is a normal as well as the tangential components. I hope you people are able to understand what is the equation of motion, what is the equations of dynamic equilibrium when a particle is moving in a curvilinear path, right? So in this case we have seen how we developed by using the Newton's second law and how we are using the modifying the inertia forces, right? So I hope you are able to understand the concepts of equation of motion for your rectangle components and equations of dynamic equilibrium. If you feel any difficulty, please put in the comment section so that I can reach you. So please follow the regular video lectures so that it will helpful to you to improve your knowledge. Thank you.